All right, everyone, in this video, we are going to talk about how to determine if two triangles are similar. So remember, we talked about yesterday that for triangles to be similar, we need to have the angles congruent. So all the angles are congruent and sides are proportional. Okay, so there are three ways that we can determine if if the triangles are similar. One way is by angle. We just need two angles from one triangle, okay, that are congruent to two angles in another triangle. Okay, so just two of the angles, we don't need the third. The next one is side. So if all of the sides are proportional, so they have to be that proportion. So when we go ahead and simplify, you'd get something like 1/2 equals 1/2 equals 1/2. If they're all the same, perfect. The next one here is side angle side. This one here, you have to have two side lengths proportional, and then one angle congruent, or well, one angle from each triangle is as the included angle. Alrighty, so let's go ahead and do some examples here. So taking a look at the first example, we have two triangles here. We are told that angle A is congruent to angle D, and angle B is congruent to angle E. Well, look at that. That's two angles, so we know these triangles are congruent by angle. So we can go ahead and write the similarity statement as triangle, and I'm going to go A, B, C. And notice how I went A is a single, B is a double. So then that's going to be similar to triangle D, E, F. As you notice, A is congruent to D, B is congruent to E. So here is our similarity statement. Moving on to the next one, we're going to go ahead and do the same thing. We're going to determine whether if the triangles are similar, and if they are, we're going to do the similarity statement. Notice how it explains your reasoning here. This is my explanation. Okay, I am showing that those angles are congruent and it's by angle. That is your reasoning. So when you're doing these, you have to show your work. There's no doing it in your head. It's kind of like a proof. If you don't show the work, I'm not going to give you points for it. So keep that in mind as you are doing these problems. So taking a look here, when you don't have any information of what sides are going to be proportional to what, the first thing I want you to look for is, let's just look for the longest side. So the longest side here is 40. It's the longest side. The longest side here in the other one is 25. Those two sides would be proportional. Okay, so if it was to work, if these triangles are going to be similar, those would be the sides that we would create that proportion with. So I'm going to say this is triangle 1, this is triangle 2. So I'm going to do 40 over 25. Next, I'm going to go ahead and look for the next one. So the next smallest here is the 20. So that's the middle. The next middle one is a 32. Oops, that's an L. All right, so then here I'm going to have that equal to 32 over 20. Notice how I'm putting triangle 1 on top and triangle 2 on the bottom. I'm keeping it consistent all the way through. And then last but not least, the smallest. So it's going to be 24 over 15. From here, you're going to go ahead and reduce each one of these fractions. So go ahead and do that. Pause the video so you can go ahead and do those calculations. All right, so you will get here 8 over 5 equal to 8 over 5. That reduces 8 over 5. And then 24 over 15. Let's check to see what that reduces to. And we get 8 over 5. So they are all going to have that same scale factor. So that is what this represents, is the scale factor. Because if we were going to go from the big triangle to the small triangle, or the small triangle to the big triangle, if we multiply or divide by this fraction, depending on which way you're going, you will get that next triangle, which is awesome. So here we can write that similarity statement. So taking a look here, look at how you set these proportions up. We have 40 and 25. Okay, 40 and 25, and then we went to 32 and 20. So let's go that way. I'm going to go IH So triangle IH, because that's that 40 side, and let's go to the 32 because I have that next. So that's going to be G. So then that'll be similar to our triangle. Go from the longest side, so SR. Then the next biggest or next longest side, Q. So here's our similarity statement. The next one here, let's take a look. So we are just given two sets of sides and a pair of angles. So we know that angle K is congruent to angle R. Beautiful. So we have an angle. Let's see if these sides are proportional. So triangle 1, triangle 2. So I'm going to have 8 over 4. Set that equal to 18 over 9. That simplifies down to, and notice how I did triangle 1 over triangle 2. Okay, so I'm going to go ahead and simplify that, and I'm going to have here 2 over 1 equals 2 over 1. Notice how I'm showing all of that work. You have to show every single step for it to count, for you to be providing that reasoning. So here we can prove these to be similar by side, angle, side. So our triangle congruency statement, I'm going to start with the angles. So I'm going to say K, something similar to triangle R, right? And then I'm going to go to the 8 and the 4. Those are the two shortest sides so far that we have. That goes to D and then J. So then this one will go from P to Z. All right, so then our triangles are similar. So the next here is just a whole bunch of examples that we have. Okay, so taking a look here, I'm going to just go through a couple of these here. And then after that, if you'd like to pause the video, do the next two on your own and then push play. The answers will be there. So I'll do the first one though with you. So remember when you have parallel lines, if it helps to extend these lines a little bit longer, go ahead and do it. I highly suggest it. It'll make things a little easier as you're going through. So then when we're looking at that, I see here that these two are corresponding angles and these are corresponding angles. Okay, so that means in our small triangle compared to our big triangle, we have two sets of angles congruent. So angle R is congruent to angle TSL, and then angle U is congruent to angle SLT. So here we have angle, angle, so we can go ahead and say our triangles are congruent, or sorry, not congruent, similar. So we have triangle RTU is going to be similar to triangle STL. Okay, so at this point, go ahead and pause the video, and when you come back, I will have the next two examples done. All right, so go ahead, take a look here. We get that second example. These two triangles are similar by side, angle, side. And the final one is not going to be similar even though they have that angle, which is wonderful. The sides are not proportional because when you reduce them, they have different scale factors. So it is not going to be similar. The next example here, we are going to go ahead, take a look at the triangles and find the missing measure. So I'm going to do the first two examples, and then you can go ahead and follow with the next two, and you can go ahead and check my answers at the end. So taking a look here, these are going to be similar triangles, but I want you to identify that similarity statement. You got to get used to it. The more you get used to it, the more comfortable you are writing it, the easier these will become for identifying those parts. So here we have X, Z. So we have a single arch and then the right angle. So I'm going to do that same order. So we have the J and then the L. So then lastly we have a Y and a K. Alrighty, so taking a look here, I know that we are going to have that 10 over 20. Okay, and then over here, and actually let me rephrase that. Let me write it this way. So I know that XZ is going to be proportional to JL. I know that ZY is going to be proportional to LK. And then lastly, we have XY is proportional to JK. So from here, if it makes it easier to write it out this way to then get your next step, please do that. So we have XY, we don't know what that is. So I'm going to write these as the fractions though. So I'm going to say this is triangle 1, this is triangle 2, and I'm going to write these as triangle 1 over triangle 2. Okay, so over here, we don't know what that is on the top, so that's going to be a 35, and then something there. ZY is 10 over 20, and then XY, oh, actually, this is I messed this first one up. This is actually 13 over x, and this is the one where we don't know the numerator, but we know the denominator is 35. Okay, so since we don't know anything about this guy here, we're just going to kind of ixnay it and not focus on that right now because we need to just solve for x. So I'm just going to take these two and go ahead and set them equal. So we have 13 over x equals 10 over 20. My suggestion is make your life a little easier and let's reduce this. So we can divide the numerator and denominator by 2. Actually, we can keep going and go by 4. I'm sorry, 5. So I'm going to divide it actually by 5. So then here we will get 13 over x equals 2 over 4. So then from here we'll cross multiply. And when we cross multiply, you'll do 13 times 4. We'll get 52 equals 2x. Divide that by 2 and you'll get x equals 26. Okay. Next example here. Remember to look at these as separate triangles. So we have this first triangle, and then we have the larger triangle. Okay? All right, so taking a look here, we need to figure out this side here. So for no, these triangles are similar, I'm going to label this as triangle. GHW is going to be similar to triangle. G is congruent to itself. And then we have IU. Okay, so taking a look here, I really just want to focus on this HW and IU. So I'm going to have HW is proportional to IU. We know this side entirely because 26 plus 13, 26 plus 13, we are going to get 39. So that's actually the length of GU. So I'm going to be looking at GW and let me put my segments on top of there, and GU, because notice here we have GW and GU. We're not looking at UW. There's no such thing here as UW. So taking a look, I'm going to write those proportions. So HW, that's 20 over X. And then the next one, GW, we have here is 26 over 39, because you're doing that whole side. Remember, you have to think of these as those separate triangles. So what we're going to do is we're going to set them equal. So 20 over x equals 26 over 39. So we can ask ourselves, can we reduce that? So 26, let's say, divided by 3. No, that doesn't work. 6, 7, 8. It looks like they aren't going to have anything in common to reduce. So we're just going to go ahead and do 20 times 39. And we're going to get 780 equals 26x. Divide that by 26, we're going to get x equals 30. All right, so here we are. This is all that I'm going to do for these notes. If you have any questions, let me know. Go ahead and do these next two examples. Remember to follow what I was doing as looking at these as the bigger triangle. So focusing on this next one here. This is the one triangle. This is your triangle 2. Okay, so think of these as separate triangles. If you need to draw them separate, I suggest it. It might make things a lot easier for you. All right, if you have questions, let me know.